Our next type of equation is called a radical equation. So let's look at what is a radical equation. A radical equation is an equation that contains a square root or a cube root or a fourth root, something to that effect. So we're looking at a problem that either has a square root or a cubed root, etc. To solve, we want to isolate the radical, meaning you want to get that radical by itself on one side, and then you want to raise both sides to an appropriate power. So what you want to remember here is that if you have a square root that you want to get rid of, that you're going to be raising it to the second power. And if you have a cubed root that you want to get rid of, you want to raise it to the third power. And if you have a fourth root that you want to get rid of, you'll raise it to the fourth power. All right, and then we have an example here on the bottom that we're going to work in just a second. The cubed root of 2x minus 4 and minus 2 is equal to 0. All right, so let's go ahead and take a look at that example. All right, keeping in mind our steps, the first step is to isolate the radical. So that means to get the cubed root part of this problem by itself. So the problem is this minus 2 that's sitting outside the cubed root. So I'm going to move that to the other side by adding 2 to both sides of the expression. So that's going to leave me the cubed root of 2x minus 4 is equal to 2. So that's the first step. Get that radical by itself on one side of the equation. Then raise both sides of the equation to the appropriate power. So again, if we're talking about a cubed root, to undo a cubed root, we're going to raise both sides to the third power. And we have to do it to both sides to keep the equation equal. So when you raise a third root to the third power, they sort of cancel each other out. And the only thing that you're left with is what's underneath, which will be the 2x minus 4. Okay, 2 to the third. You can either put that in your calculator, or you can remember that 2 to the third is really just 2 times 2 times 2. So 2 times 2 is 4. Times 2 again is going to give you 8. So our expression now becomes 2x minus 4 is equal to 8. And now it becomes a linear equation. Remember, no exponents become a linear equation, and so our job is just to solve it for x. So I want to deal with this minus 4 first. So I'm going to undo it by adding 4 to both sides. So we're going to have 2x, the 4's will cancel, is equal to 12. And again, solving for x, so this 2 times x has to be undone with division. We're going to divide both sides by 2. And so our answer is going to become x is equal to 6. Okay, let's take a look at another one. So our equation this time is the square root. Okay, and you do want to keep in mind that if you do not have a power right here, the assumption is that it's a 2. So the square root of 4x plus 21 is equal to x. Step 1 is to get your radical by itself on one side of the equation. So that's actually already done. Step 2 is to raise both sides to an appropriate power. So if we're talking about a square root, we're going to raise to the second power. And you're raising both sides of it to the second power. Remember, when you take a square root and you square it, they cancel each other out. It leaves you what's underneath. So it leaves you 4x plus 21. And then on the right-hand side, you just have an x squared. So now we have to think about what type of equation this is. The highest power is 2. That makes it a quadratic equation. How do we solve quadratic equations? What we talked about in this section is that we solve by factoring. So I'm going to go ahead and get this set up and get it ready to factor. Remember that in order to factor, you have to have everything on one side of the equation and 0 on the other side. So I'm going to first move the 4x to the other side. So it's going to cancel here. It's going to leave me 21 is equal to x squared minus 4x. And then remember, I'm moving everything to one side, so I'm going to subtract 21 from both sides. And so my quadratic equation is x squared minus 4x minus 21. Now the reason I moved everything to the right is because it is easier to factor if your x squared term is positive. All right, so let's look at what we've got here. So I have x squared minus 4x minus 21, and I'm going to try to factor this thing. All right, so recall what you put here and here need to make the first term. So that part is fairly easy because the only way I'm going to make x squared is I'm going to multiply x times x. Now, the terms that I put in the back two spots need to multiply together to give me 21. Well, when I think about the ways that I can make 21, I can either multiply 1 times 21, or I can multiply 7 times 3. I need a way where my middle term is going to somehow end up being a 4. So I can't really add or subtract 1 and 21 to make 4. So I'm going to eliminate that option. 7 and 3, I can do 7 minus 3 and get 4. And so that's likely going to be what I need to place in my blank. So I'm going to go ahead and put a 7 in one and a 3 in the other. Now we need that 4 to be negative, which means that the bigger term needs to be negative in my expression. So I'm going to put a minus 7 and a positive 3. Now, you should always do a quick check to make sure that you have this thing factored correctly, and you can check it by foiling. So very quickly we could say first terms would make x squared, outside would make 3x, inside would make negative 7x, and last would make negative 21. And then when I combine those middle terms, I get x squared minus 4x minus 21, which is exactly what I started with, which tells me that I have it factored correctly. Once you have it factored correctly, then remember that you're going to take each term and you're going to set it equal to 0. All right, and so then we're going to solve each one. So on the first one, we're going to add 7 to both sides. And on the second one, we're going to be subtracting 3 from both sides. So our two answers, x is equal to 7 and x is equal to negative 3. And again, it's not a bad idea to plug your numbers into your original equation and make sure that they actually work. Right? For example, if I were to plug a 7 into the original equation, I'm going to have 4 times 7 plus 21. And I want that to equal 7. So 4 times 7 is 28 plus 21. That's going to give me 49 underneath. and the square root of 49 is 7. So we know that that is actually one of the solutions. All right, but let's look at the other one. If I take 4 and multiply by -3 and add 21 and put that underneath the square root, I want that to equal -3. So 4 times -3 is -12 plus 21. And so what do we end up getting there? All right, so that's going to give me the square root of +9. And the square root of +9 is +3, which does not equal -3. And so this is considered to be what we call an extraneous solution, and we're going to throw it out. So our only answer to this problem is x is equal to 7. All right, let's take a look at this last problem. So again, the first step is to isolate the radical, which is already done for you. Notice your square root is by itself on the left-hand side. The next step is to raise both sides to an appropriate power. So since we're dealing with the square root, we're going to raise both sides to the second power. When you square the square root on the left, remember that it cancels out. So you're left with 21x minus 24. Now, when you square the x plus 4, on the right-hand side, you need to use your FOIL method. So this is a common place where students make mistakes. You want to remember that x plus 4 squared is x plus 4 times x plus 4. So when we FOIL that out, we'll get x squared plus 4x plus 4x plus 16. And so we have x squared plus, combining those middle terms, 8x plus 16. So what kind of equation do we have now? We have a quadratic equation because we have the highest power of 2. So remember, quadratic equations so far are solved by factoring. So we're going to move everything to one side of this equation. So I'm going to begin by subtracting the 21x. So that's going to give me -24 is equal to x squared minus 13x plus 16. Then I'm going to add 24 to both sides, which is going to give me the 0 that I wanted on the left. And then on the right, x squared minus 13x plus 40. And now we're set up to factor. So in order to make x squared, I know that it's going to be x and x. Let's think about how we want to make 40. So 40 can be 1 times 40. It could be 2 times 20. It could be 3 times 10. No, it could be 4 times 10, sorry. It could be 5 times 8. And we need an expression or a set of numbers that will somehow combine, either adding or subtracting, to make 13. So the solution that we want to use is the 5 and the 8. Now we want that 13 to be negative. which means that we're going to need a -5 and a -8 added together to make -13. Once we have the expression factored, we're going to set each factor equal to 0 and solve for x. So in the first one, we're going to add 5 to both sides. And in the second one, we're going to add 8 to both sides. So we have one answer, x is equal to 5. And we have one answer, x is equal to 8. And again, you would want to check these answers to make sure that they are both correct. All right, so let's check them real quick and make sure. All right, I'm going to start with the 5. So I'm going to plug in the 5 for the x on both sides of the original equation. So 21 times 5 minus 24 is going to give me 81 on the left. 5 plus 4 is 9, and we know that the square root of 81 is 9. So that's going to be a solution. Let's try the other one. So I'm going to plug the 8 in. So 21 times 8 minus 24 is equal to 8 plus 4. So 21 times 8 minus 24 is 144. Is equal to 12. And we know that the square root of 144 is equal to 12, and so this is also a solution to the problem. So our answers are x is equal to 5 and x is equal to 8.